At this very moment, a gigantic dam is taking shape without a single human worker needed to transport cement, operate tractors, or even walk around the construction site. There are absolutely no people present, as the entire operation is managed by artificial intelligence and carried out by a fleet of robotic machines working non-stop day and night. Far from being a miniature test or a virtual lab, this is a real hydroelectric plant, an impressive 180 meters tall, located on the Yellow River in China. If this scenario seems hard to believe, know that the surprise is shared by many. But first, don't forget to like and subscribe to our channel. When researchers at Tsinghua University published the scientific paper detailing the initiative, engineers around the world had to review the text to make sure it wasn't a misreading. A dam equivalent to a 60-story building, being shaped layer by layer exclusively by robots, without any direct human intervention, is a scenario that shines a spotlight on a rather uncomfortable question for the global construction industry. Has our workforce already become obsolete? Named the Yangkou Hydropower Plant, the complex is located on the upper reaches of the Yellow River, in Qinghai Province, on the Tibetan Plateau. The Yellow River holds millennia-old significance for Chinese civilization, being the country's second longest waterway. The dams built along its length play crucial roles in flood control, agricultural irrigation, and electricity generation for a population of hundreds of millions of people. The Yangkou facility is not being built from scratch, as it was already operating on a smaller scale. Development of the initial plant began in 2010, and the power plant, with a capacity of 100 megawatts, began operating in 2016. However, China's ambitions were far more ambitious, and the goal was to significantly expand the dam, raising its height to the current 180 meters and drastically increasing its power generation capacity. The question was how to do this in one of the most hostile construction environments on the planet. The answer turned out to be something no one had attempted on this scale: handing all the work over to machines and letting artificial intelligence run the operation. When most people hear about 3D printing, they imagine a desktop printer depositing plastic layer by layer to create a small object. But that's not what we're talking about. There is no giant extruder nozzle pouring concrete here. Instead, the team at Tsinghua University has reimagined the entire construction site as a massive distributed 3D printer. The machines themselves are the print head. The Tibetan Plateau is the printing platform, and the material used is roller compacted concrete, RCC, a dry, rigid concrete mix developed specifically for dam construction. The entire approach utilizes what engineers call the principles of additive manufacturing. Each layer is positioned, spread, and compacted one step at a time, causing the dam to grow progressively from the ground up. Artificial intelligence manages the entire process, determining the exact location of each layer, the ideal thickness, and which equipment will perform the task. It is a 3D printing process, but on a scale that makes household devices seem like mere miniatures. Unlike the conventional method, in which organization relies on field supervisors coordinating separate teams, in this scenario, all actions are centralized by a single digital hub. At the heart of the operation, an artificial intelligence system functions simultaneously as project manager, field supervisor, and quality control auditor. This technology constantly analyzes the information collected by sensors spread throughout the perimeter. It evaluates the properties of the materials, weather variations, soil characteristics, and the real-time performance of each vehicle in the fleet. Based on this data, the system creates execution plans, delegates tasks to specific robots, adjusts the mix of supplied materials, and reroutes machinery if it detects any anomalies. Scientists at Tsinghua University have compared the structure to a fully automated production line, with the unique feature that this conveyor belt operates along a valley between mountains to build a dam. If the technology detects that a batch of concrete is outside the standard moisture range, it immediately halts paving in that sector and redirects efforts to another area. This ability to adjust instantly is something that cannot be achieved with the same speed by teams of people. Professionals require time to assess scenarios, discuss alternatives, and make a final decision. The electronic brain resolves the issue in fractions of a second. The operational contingent consists exclusively of autonomous vehicles, with each unit fulfilling a specific role in this system. The process begins with robotic excavators that extract and collect materials in designated areas. Shortly thereafter, a convoy of driverless trucks transports this load to the application sites. Once the materials are delivered, unmanned tractors and pavers distribute them evenly across the top of the structure. Next, smart rollers, equipped with internal sensors, compact each layer until the required millimeter-level density is achieved to ensure the stability of the structure. The role of these rollers is vital. In conventional engineering methods, achieving perfect compaction is one of the most complex and physically demanding tasks. Pressure below the required level can cause soil settlement and cracks later on. Excess pressure, on the other hand, leads to wasted time and fuel. The AI-guided rollers consistently achieve the perfect level as they operate by receiving real-time data on specific gravity, moisture content, and layer height. This level of precision is something human workers strive for but rarely maintain throughout an entire 10-hour shift. Given this, the question arises as to why China chose to implement this innovation in such an isolated region with such a hostile climate. The Tibetan Plateau is situated at an average altitude of over 3,000 meters. The air is thin, temperatures vary drastically, and the weather can become extremely harsh without warning. Construction workers at this altitude face oxygen deprivation, altitude sickness, and a significantly higher risk of accidents. In the past, building large infrastructure projects under these conditions required bringing in thousands of workers, housing them in temporary camps, and accepting that the work would be slow, dangerous, and expensive. By replacing human workers with robots, China eliminates all these problems. Machines don't need oxygen, don't suffer from altitude sickness, and don't require heated housing or medical facilities. They simply work. And that makes the Tibetan Plateau the perfect testing ground for autonomous construction technologies. If these robots can build a dam there, they can build it anywhere. It's hard to argue with that logic. The most hostile environment on Earth is exactly where you want to test your toughest technology. Let's put the Yangkou Dam into perspective. At 180 meters tall, it is a gigantic structure, but it is not the tallest dam in the world. The Hoover Dam, for example, is 221 meters tall. China's Three Gorges Dam itself is 181 meters tall and stretches over 2.3 kilometers along the Yangtze River. What makes Yangkou extraordinary isn't its absolute size, but the way it's being built. Prior to this project, the world's tallest 3D printed structure was a two-story commercial building in Dubai, about 9 meters high. Yank is 20 times taller. This isn't just a step forward. It's a completely different category. The leap from printing a small building to constructing a dam capable of generating billions of kilowatt hours of electricity is like going from a paper airplane to a large jet. No one in the construction industry expected such a huge leap in such a short time. When the Yangkou expansion is fully operational, it will generate approximately 5 billion kilowatt hours of clean energy every year. That is enough to power a city of several million people. The electricity will be transmitted to Henan province in central China, home to nearly 100 million people, feeding a power grid that is gradually moving away from its reliance on coal. China already leads the world in installed renewable energy capacity, and projects like Yangkou are an important part of that strategy. The schedule called for the first turbine of the expanded complex to begin operating by the end of 2024, with the plant fully operational the following year. Every kilowatt hour generated by Yangkou represents 1 unit of energy that is no longer produced by burning coal. For a nation that still derives most of its electricity from this fossil fuel, the impact is enormous. This dam goes beyond a simple engineering test. It represents a crucial pillar in the sustainable shift of China's energy mix, gaining even greater significance because it is being built using automated machinery. If this independent execution model enables clean energy projects to be completed more quickly and at lower cost, the financial viability of the renewable energy sector will take a historic leap forward. The Yangkou project goes beyond the concept of a mere physical barrier. It is a practical validation with the potential to revolutionize the engineering of major projects around the globe. If the 3D robotic modeling coordinated by artificial intelligence proves efficient on a structure 180 meters high, the same logic could be replicated on overpasses, roads, retaining dikes, and other large-scale projects. Countries suffering from labor shortages, severe weather, or hazardous working conditions could implement similar technologies to develop their infrastructure without exposing people to danger. On the other hand, profound dilemmas come to the fore. What will become of the countless construction workers who risk losing their jobs to automation? Can software truly resolve all the complex unforeseen issues that engineers routinely face on construction sites? And would it be entirely safe to rely on this technology when dealing with structures where any error could cause a disaster of immense proportions? These are questions the market will have to answer as the system evolves. In any case, one reality is already clear. The Yangkou project has proven that the next chapters of heavy construction do not necessarily depend on uniforms and manual labor. In some cases, all that is needed is a digital brain and a battalion of tireless machines.